good afternoon, everybody, or may I say evening. We are few heroes here, and it's happy to see so much heroes here. And let's talk about AI and all its revolution, and especially in the defense and aerospace industry. And I'm delighted to be with Renaud Allioux and Yonatan Teboul, and we can begin like that. Could you both please introduce yourself and your missions? Thank you very much.
So I can start. So I'm Renaud, co-founder of Preligens, now Severin AI. So Preligens is a startup who we are developing AI for defense solutions, especially intelligence and image with our video of images, especially satellite images. And we have been acquired by Severin 2 weeks ago, officially. So we are now Severin AI.
So hello everybody, I'm Yonatan Teboul. So I'm working for MBDA. MBDA is the European leader of missile systems. We are developing and maintaining systems that serve the defense of Europe and are spread across Europe in 4 main countries, delivering the capability to defend ourselves, both as well and our partners and I in the world.
Thank you. And we will have 3 matters, 3 issues, or I should say challenges. The first one will be the integration of AI into legacy system. The second one will be the use cases on the battlefield with AI. And the last one will be the ethical consideration. So we can begin with Yonatan. How can we integrate AI models, new technology, into older architecture in terms of hardware and software?
So, okay, first of all, we'll distinguish between products and services. Maybe today, a lot of other speakers talk about new services or operational efficiency gains through AI. For services, we can host servers and maintain an architecture that can, where we can deploy relatively easily AI systems, so to sort a lot of data. So this is the main use case of AI, I think, for services or for operation efficiency gain. So it is relatively easy because it is within the IT architecture, the enterprise IT architecture. So you can get data from the customer, or you have your own data where you can offer new services through AI. But here, maybe we can talk about what distinguishes MBDA from the other players is the ability to compute at the very edge. So it is about edge computing. You have to compute a number of operations with a small amount of power and energy. So that is why we are both having an approach to complete legacy architecture with new computing power, could be possibly GPUs, but as well to integrate into the next generation of our weapon controller. We call it weapon controller. It's an electronic module that resists a lot of constraints, be it thermal or mechanical, and in a tiny amount of energy. So, and for this one, we are more talking about timescales that exceed 5 years. So we prepare to integrate new algorithm, possibly based on the AI techniques in this kind of system. But as well, we have to be able to compute at the very edge for other use cases. When we can, we complete with another, I would say, upgrade component where we can host those AI systems. And I think it's not AI systems. This is mostly software where we run AI algorithm in it. It is just I think it's not AI systems. The right thing to talk about is the way we can integrate it relatively easily, and for it, the bottleneck is the memory, is the ability to run those large neural network. And again, the same challenge with images, because we process images, we process radar signal, like Renaud is doing for image reconnaissance as well.
Thank you. And Renaud, what do you think about this challenge from your point of view?
I think first, the first thing to do, as you say a little bit, is also to have something which is not very common in the software industry, is to have a system design approach. So we are used to, in software and AI and everything like this, is to deliver software. Like I build my software, I deliver it, and this is the minimum requirement you need. You need to put Windows XP or Ubuntu, or this version of Ubuntu, etc. This is not how it works in the defense and aerospace. You need really to think this about like as a design system. Like the system is hardware, is software, is AI, and you need to think this as a whole. And this is actually system design. I used to come from Airbus, and they talk a lot about system design and different components. So I think this is the first thing, like to think AI, hardware, and software as a global system, and to develop both, to develop all these components with cross iteration. And also, I think a good way to anticipate it is to have flexible and upgradable hardware, but that could host different services and are like standardized and use like open source architecture or common component, and that which is make it simple to integrate different provider or different services. For example, for GPUs, you have like Jetson series GPUs, this kind of thing. It allows you not only to have like computing power, but also allows you to have like to be compatible with different kind of services, and this is quite interesting.
Thank you very much. And Yonatan, we know that on the battlefield, sometimes it is a matter of seconds or minutes, but a lot of times it's a matter of seconds. So how do we integrate AI into systems that require immediate responses?
Yes. First of all, so when you talk about AI, we are talking about the augmentation of the performance of the system. And in a lot of cases, you have an operational envelope, a domain of use of your system. And in most cases, AI in the battlefield open up new domain of use of your system. For example, today with the use of drones in the battlefield, you can collect relatively easily images. But we all know drones are jammed, but we can overcome jamming with image-based navigation using artificial intelligence. And it's like having those new data sources that operate resiliently and connected with our legacy system to provide data to detect potential threats, to help the operators neutralize these threats and operate in a new domain of use, because in one case, you cannot defend yourself because you are not connected or you are not aggregating new data or processing new data with the use of AI components. And with the deployment of AI components at the edge and with the use of new data sources like drones, you open up new operational use. And I think what is very important today is you provide this to the operators, the warfighters, but you can as well upgrade relatively easily or even retrain the model on the field. I think it's far-reaching, but we have to give this flexibility to the operator in some case to be able to add new threats in their spectrum and give them a framework to possibly upgrade those AI components. And that is the route that we are taking, is to offer more flexibility for the warfighter to use and to make benefit of all this new data. And I think seeing through the cloud.
Thank you very much, Yonatan. And Renaud, in your opinion, how can these AI models can adapt to the dynamic and complex environment of the battlefield?
Yeah, so I think the first thing when we talk about like the battlefield and AI, and I think it's general to find all AI application. Like AI works, like we all have seen ChatGPT, we all have seen like before like algorithms that can detect lots of different stuff on images. The point is not like does it work technically. The point is to have operational usage, and especially in the battlefield where you need like second but a very good performance, operational usage that give value. So adoption, use cases. This is for me the next frontier in AI, because we see lots of AI application. We don't see lots of companies making lots of money with AI. And at the end, you need an AI which has an adoption, a use case bring value, making money for the company, because at the end, the company needs to make more money than it spends. So this is the key, and I think this goal are like you need to talk a lot to the user to choose a lot your use cases. And what we are focusing on in our case is really to help people on the battlefield, whether they are like soldiers on the field or generals, like having the ability to make better decisions. And you do that by processing data and making sense of this data. We have more and more data, video flux, where more and more data coming from satellites, from drones, from different cameras, but we don't have more and more people to look at them. And so we need to really focus on bringing value by like simplifying decisions, not making them more complicated. And this is where we are working with Preligens since and now Severin AI since the beginning, like trying to bring value by really working close to the use cases, working close to the customer, to be sure like we end decision making, in fact.
So Renaud, what's the right mix between human judgment and the AI assistance?
So I think really what everybody agrees in the defense industry is like the human is in the loop and the human makes the decision. The human, it's about making better decision. And I really think that making better decision in the context of like military operations save life. Like you have a better you have less fog of war, you have better field of view, you are more reactive when something happens, and so you can like have like more informed decision, and more informed decision actually save lives, because you have less collateral damage, you have less mistakes, you have more accurate position of everything what's going on. So yes, human in the loop, human getting the information, AI filtering and making sense of the information. In the intelligence, we make the difference between information and intelligence. Like you have usually you can have lots of information. If you look at Twitter, you have lots of information. You don't have any intelligence. Intelligence is making sense of the information, and this process can be automated a little bit by AI in some cases, and this is where we try to focus.
Thank you, Renaud and Yonatan. In order to conclude this brilliant session, can AI truly be more reliable than human methods?
I think it would be a no for me today. I think it's like Renaud was talking about what we call in this use case, which we are today. In the short term, we provide decision aids for operators. Today, this is the current use case. We are not providing robots with AI like this. It's decision aids first, and it's about human-machine teaming at the very end. So you augment the operators with the ability to see a lot of data, but you have to pay attention with a number of factors. So you have to integrate method and tools as well for the engineer to be confident to integrate those new decision aids in the system. For example, we can have a lot of issues with false alarms that we cannot lead the operator to bet on a decision which is false. So we cannot as well make the operator be in a position to be, I will say, overloaded, for example, with false alarms. So that's why fine-tuning and having the ability to really design human-machine teaming for decision aids is crucial for me.
Thank you very much, and over to you. We are finished.